Look up at the night sky. Thousands of stars, millions of worlds, and yet, as far as we know, life, intelligent, complex, conscious life, exists on only one, Earth. A pale blue dot drifting in the vastness of space. Not too hot, not too cold, with oceans of water, a breathable atmosphere, and just the right kind of sunlight. But how did this happen? Why here? Why us? It turns out, Earth's ability to host life is no accident. It's the result of a fragile and extraordinarily rare alignment of cosmic circumstances, a delicate balance between forces seen and unseen, near and unimaginably far. From the glow of our sun to the pull of our moon, from the magnetic heart beneath our feet to the giant planets protecting us from destruction. Every detail matters. This is the delicate balance. Earth orbits the Sun at just the right distance, about 93 million miles or 150 million kilometers. This region is called the habitable zone, or more famously known as the Goldilocks Zone. Not too hot, not too cold, just right for liquid water to exist on the surface. If Earth were even a few percent closer to the Sun, our oceans might have boiled away like they did on Venus. A few percent farther, and we might have ended up a frozen, barren rock like Mars. But it's not just where Earth is, it's how it moves. Earth's orbit around the Sun is remarkably stable and nearly circular. A more elliptical orbit would cause wild temperature swings, scorching summers followed by deep freezes, not exactly ideal for stable ecosystems. Instead, our seasons come with predictability, giving plants, animals, and even human civilizations the rhythm they need to survive. And then there's the tilt. Earth's 23.5-degree axial tilt gives us seasons, which help spread sunlight across the globe more evenly throughout the year. Without it, regions near the poles would freeze solid, and equatorial zones would become scorching hot wastelands. Even Earth's rotation speed plays a part. A 24-hour day provides just the right amount of sunlight to warm the planet during the day and allow it to cool at night. A slower rotation would cause extreme heat during the day and deep cold at night, while a faster one could produce chaotic weather systems. So when we talk about Earth's place in the solar system, we're not just talking about distance. We're talking about an exquisite dance of orbit, spin, tilt, and timing. A cosmic alignment that so far appears to be extraordinarily rare. At the center of our solar system burns a star we often take for granted, the Sun. It's easy to overlook, rising and setting every day without fail. But this one star is the reason Earth exists at all, let alone teems with life. And more than that, it's the right kind of star. The Sun is a G-type main sequence star, stable, moderate in size, and remarkably consistent in its energy output. That stability matters more than most people realize. Many stars in the galaxy are far more volatile. Red dwarfs, for example, are the most common type of star, but they emit intense solar flares that could strip away a planet's atmosphere. Larger stars, like blue giants, burn through their fuel quickly and live only a few million years, far too short for complex life to develop. But our Sun is different. It's been shining for about 4.6 billion years, and it has at least another 5 billion to go. This generous timeline gave Earth the breathing room it needed, not just for life to emerge, but to evolve from single-celled organisms into intelligent, self-aware beings. The Sun's energy output is also just right. It radiates most of its energy in the visible light spectrum, perfect for photosynthesis. Plants convert that sunlight into energy, forming the base of the food chain and pumping oxygen into our atmosphere. Without that balance, too much radiation, or the wrong kind, photosynthesis might not work, and the entire system collapses. Then there's the sheer gravitational force of the Sun. Its immense mass keeps the solar system in order, holding planets in stable orbits like beads on an invisible string. If the Sun were less massive, its gravitational pull would be weaker and Earth could drift or be pulled away by another star's influence. Too massive, and its lifespan would be cut short. And finally, there's the Sun's magnetic influence, the heliosphere. This vast bubble of solar wind extends far beyond Pluto, shielding the solar system from much of the cosmic radiation coming from deep space. It's another layer of protection that helps Earth remain a cradle for life. So when we talk about the Sun, we're not just talking about a light in the sky. We're talking about a perfectly balanced, long-lived, nurturing engine of energy. A cosmic furnace that, against all odds, burns with just the right intensity, at just the right distance, for just the right amount of time. Without it, Earth would be a frozen rock, or worse, a scorched wasteland. With it, we have blue skies, green forests, oceans full of life, and the possibility to ask how we came to be here at all. When we think about what makes Earth habitable, we often focus on the Sun. But there's another celestial body that plays a crucial and often underappreciated role in the story of life: the Moon. At first glance, the Moon seems quiet, still, and lifeless, but its presence is anything but passive. In fact, without it, life on Earth, if it existed at all, would look radically different. Let's start at the beginning. Scientists believe the Moon was born out of a colossal collision over 4 billion years ago. A Mars-sized object named Theia slammed into the early Earth, ejecting molten rock and debris into orbit. Over time, that material coalesced and cooled, forming the Moon. This violent origin is what gave us a relatively large moon compared to our planet's size, something that's exceedingly rare in the universe. The Moon's gravitational pull stabilizes Earth's axial tilt. Without it, our planet would wobble unpredictably, like a spinning top losing momentum. Over time, Earth's tilt could swing wildly, anywhere from almost no tilt to 85 degrees. The result? Climate chaos. Imagine Antarctica in permanent daylight, while the equator plunges into darkness. The stability provided by the Moon gives us consistent seasons, reliable weather, and a climate that's remained relatively friendly to life for millions of years. The Moon also powers the tides, pulling on Earth's oceans with its gravity. These tides do more than shape coastlines. They stir the oceans, cycling nutrients, oxygenating water, and supporting marine ecosystems. Early life may have depended on the tidal rhythms, especially in shallow coastal pools where complex chemistry could take hold. Even today, tides influence the migration, spawning, and feeding of countless marine species. Take the Moon away, and you weaken these tides dramatically, by up to 75%. Coastal ecosystems could collapse. The delicate balance of temperature, salinity, and nutrient flow in the oceans would be thrown off, with ripple effects through the entire food web. And the Moon's influence doesn't stop there. By interacting with Earth's rotation, the Moon gradually slows the planet down. Long ago, a day on Earth lasted just a few hours. Thanks to the Moon's gravitational tug, Earth's spin has slowed to the 24-hour rhythm we know today. That regular cycle helped shape biological clocks, circadian rhythms, in everything from humans to animals. There's also growing evidence that the Moon may have played a role in the origin of life itself. The tidal forces it creates might have caused wet-dry cycles in early Earth's tidal pools, cycles that concentrate organic molecules and encourage the formation of complex chemistry, possibly even the first strands of RNA. And on a more poetic note, the moon has inspired myth, timekeeping, storytelling, art, and exploration. It gave ancient civilizations a way to measure time, guided nocturnal hunters and sailors, and became the first celestial body humans ever set foot on. Without the moon, Earth might still be a planet, but it wouldn't be this Earth. So next time you look up at the night sky and see that familiar glow, remember, the moon isn't just a rock, it's a guardian, a stabilizer, a silent architect of life. Earth is more than just a rock with an atmosphere. It's a living system with layers of complexity that reach from its surface all the way down to its molten heart. Deep beneath our feet, about 3,000 kilometers below the surface, lies one of the most important protectors of life, Earth's liquid iron outer core. It's constantly churning, spinning, and flowing, generating something that may not be visible, but is absolutely vital. That force is Earth's magnetic field. This invisible shield, also known as the geomagnetic field, stretches tens of thousands of kilometers into space, forming a protective bubble called the magnetosphere. Without it, life on Earth wouldn't just be endangered, it might never have evolved at all. Here's why. The sun is constantly ejecting high-energy particles in the form of solar wind, a constant stream of charged radiation moving at hundreds of kilometers per second. During solar storms, these winds can become violent, blasting space with energetic flares and coronal mass ejections. If these particles were allowed to reach Earth's surface directly, they would strip away the atmosphere over time, bombard life with radiation, and render the surface almost uninhabitable. That's not speculation. It's what likely happened to Mars. Mars once had a magnetic field and possibly even flowing water, but over time, it cooled, lost its magnetic protection, and its atmosphere was slowly peeled away by solar wind. Today, it's a cold, barren desert, blasted by radiation, with no global magnetic field to shield it. Earth, by contrast, has held on to its atmosphere, its oceans, and its habitability for billions of years, thanks in large part to the motion of its metallic core, which powers the magnetic field like a massive planetary dynamo. The magnetic field also plays a quieter but equally important role in modern life. It guides migratory animals, protects satellites and spacecraft, and even allows our compasses to work. Without it, birds and sea turtles would struggle to navigate. GPS satellites would be exposed to higher radiation levels. The modern world would be very different. But Earth's magnetic field isn't static. It fluctuates, drifts, and occasionally even reverses, a process known as a geomagnetic reversal, where the magnetic north and south poles flip. These reversals have happened many times in Earth's history, though not instantly. They take thousands of years. And while life has survived them, they likely caused temporary disruptions in Earth's radiation shielding and possibly even played a role in extinction events. Still, even with these reversals, Earth's core continues to function as a protective engine, maintaining an overall shield that protects our planet like a suit of armor. It's humbling to think, while we walk the surface of the Earth, looking up at stars and clouds, it's the spinning, liquid metal beneath us that quietly makes life possible, by keeping deadly space radiation out. So the next time you see a compass needle point north, or watch the northern lights shimmer across the sky, remember, those glowing curtains of light are the visible fingerprints of our planet's magnetic shield in action, defending life moment by moment. from a universe that never stops throwing energy our way. Floating in the outer solar system is a giant so massive it doesn't just orbit the sun, it shapes the architecture of the entire solar system. Jupiter. At over 300 times the mass of Earth, Jupiter is the largest planet in our solar system. But it's more than just a giant gas ball with beautiful storms. It's a cosmic guardian, a planetary shield that may have made Earth's long, peaceful history possible. Let's start with gravity. Jupiter's immense gravitational pull acts like a giant vacuum cleaner in the outer solar system. It captures or flings away comets, asteroids, and other space debris that might otherwise come hurtling toward the inner planets, like Earth. In fact, astronomers believe Jupiter has been responsible for sweeping clean vast regions of space, significantly reducing the number of catastrophic impacts our planet has faced over billions of years. To put that in perspective, Earth has been struck by massive asteroids in the past, like the one that wiped out the dinosaurs 66 million years ago. But without Jupiter, those types of extinction-level events could have been much more frequent, potentially wiping out life over and over again before it ever had the chance to evolve into something complex. In fact, many computer simulations of early solar system evolution show that without Jupiter, Earth might have been relentlessly bombarded by giant icy bodies from the outer solar system, especially during the chaotic period known as the Late Heavy Bombardment, about 4 billion years ago. That phase of intense collisions may have even brought water to Earth, but without Jupiter helping to stabilize the chaos, the planet could have easily been sterilized before life had a chance to take hold. But Jupiter does more than just throw things away. It also locks objects into stable orbits, like the Trojan asteroids it shepherds in its Lagrange points. It even influences the orbit of Saturn, and indirectly helps maintain the long-term stability of the entire solar system. It's no exaggeration to say that Jupiter's presence helps keep the solar system calm enough for life to thrive. Some scientists even speculate that Jupiter's role as a shield may be a requirement for habitability. In all the thousands of exoplanets we've discovered, very few systems have both rocky Earth-like worlds and giant gas planets orbiting farther out. Could it be that having a massive protector is one of the essential ingredients for life? And then there's the beauty, with its iconic bands, raging storms, and the famous Great Red Spot, a hurricane twice the size of Earth that's lasted for centuries. Jupiter isn't just a protector, it's a marvel. It reminds us how diverse and dynamic planetary systems can be. So while it may be hundreds of millions of kilometers away, Jupiter is quietly shaping the conditions that make Earth what it is. It doesn't shine like the sun, or tug on our tides like the moon, but from the shadows of space, it has likely shielded Earth from destruction more times than we can count. It's yet another reminder that our planet exists not in isolation, but in a vast, interconnected cosmic dance. A dance where every partner plays a role, even the giants watching from afar. Beneath the continents and oceans we stand on, the Earth is in motion. It may not feel like it, but the ground under our feet is alive, constantly shifting, reshaping, and recycling itself. This process is called plate tectonics, and it's not just a geologic curiosity. It's a life-sustaining force, one that makes Earth not just habitable, but dynamic. Earth's outer shell, the lithosphere, is broken into a series of rigid plates that float on the semi-fluid asthenosphere below. These plates move slowly, just centimeters per year, but over millions of years, their movement shapes the surface of the planet. Continents drift, mountains rise, oceans open and close, But tectonics is more than continental drift. It's a planetary life support system. When plates collide, they force rock deep into the mantle, where it melts and later resurfaces through volcanoes. This process helps regulate carbon dioxide, one of the most important greenhouse gases. Without this natural carbon cycle, Earth could either become a snowball or a runaway greenhouse like Venus. Volcanic eruptions release carbon dioxide into the atmosphere, warming the planet. Meanwhile, weathering of uplifted mountains and the burial of carbon in ocean sediments cools it down over time. It's a long, slow feedback loop, but one that's essential for climate stability on geological timescales. Plate tectonics also recycles nutrients, bringing minerals from deep within the Earth back to the surface. Volcanic soils, for example, are among the most fertile on the planet. Many of the ecosystems we rely on, lush tropical rainforests, productive farmland, are built on volcanic foundations. Without this constant renewal, Earth's surface would become geologically dead, stripped of essential elements like phosphorus, iron, and potassium that life needs to grow. It also plays a key role in the formation and movement of oceans and continents, and with them, the shaping of habitats. The drifting of land masses has isolated species, created biodiversity hotspots, and driven evolution forward through countless cycles of extinction and adaptation. The very shape of Earth's biosphere, the mountains, the valleys, the coastlines, is sculpted by tectonic forces. And then there's the magnetic field. Earlier we talked about how Earth's liquid outer core generates the magnetic field that protects us from solar radiation. But plate tectonics may help cool the planet's core at just the right rate, keeping that internal dynamo running. Without plate movement, Earth's interior might cool too slowly or too quickly, and the magnetic field could shut down, leaving us exposed to cosmic danger. Now consider this: Earth is the only planet in the solar system with active, large-scale plate tectonics. Mars had some early tectonic activity, but it died out. Venus has volcanoes, but no evidence of moving plates. Earth stands alone as a geologically active, constantly renewing system. Some scientists even suggest that plate tectonics might be a prerequisite for life. Without it, a planet may not be able to maintain stable temperatures, recycle nutrients, or protect itself from cosmic radiation over billions of years. So, while earthquakes and volcanic eruptions may seem like destructive forces, they are signs that our planet is alive, a planet with a beating geological heart, a planet that breathes. And in that slow, grinding movement of stone and heat, life finds the balance it needs to endure. Look around. Water is everywhere. It covers over 70% of Earth's surface. Vast oceans stretching beyond the horizon, winding rivers carving valleys, shimmering lakes reflecting the sky. But water isn't just a backdrop to life. It is life's foundation. Liquid water is incredibly rare in the universe. Most planets are either too hot, boiling their water away, or too cold, freezing it solid. Earth sits perfectly in that sweet spot, where water can exist as a liquid for billions of years. This stability is a cornerstone of habitability. Why is water so special? It's the universal solvent. Water molecules are polar. They cling to other molecules, pulling nutrients and chemicals into solution, allowing them to react, combine, and form the complex molecules of life. Without water, the chemistry of life simply wouldn't work. Water also acts as a temperature regulator. Its high specific heat means it can absorb and store huge amounts of heat energy without dramatically changing temperature. This property helps stabilize Earth's climate, moderating extremes and creating a relatively mild environment that supports diverse ecosystems. The cycling of water through evaporation, condensation, and precipitation, the water cycle, moves nutrients through the environment, replenishes soils, and sustains plants and animals. It connects the atmosphere, oceans, and land in a continuous flow. Even inside our bodies, water is crucial. About 60% of the human body is water. It transports oxygen and nutrients to cells, removes waste, regulates temperature, and cushions joints. Life as we know it depends on this simple yet extraordinary molecule. In early Earth history, water may have been delivered by icy comets and asteroids, possibly influenced by Jupiter's gravitational nudges. This influx created vast oceans that became cradles for the first life forms. Tidal forces, driven by the moon, stirred these oceans, creating dynamic environments ideal for prebiotic chemistry. From microscopic plankton drifting in sunlit waters to the blue whales roaming the deep, the ocean's vastness sustains a complex web of life. Coral reefs, often called the rainforests of the sea, thrive in these waters, providing shelter and food for countless species. Water shapes the very geography of our planet. Rivers carve canyons, glaciers sculpt mountains, and waves reshape coastlines. It is a force of erosion and renewal, constantly transforming the Earth's surface. Beyond Earth, astronomers search for water on other worlds as a key indicator of potential habitability. Finding liquid water is the top priority when looking for life beyond our planet. Because, simply put, without water, life as we know it cannot exist. So when you drink a glass of water, swim in a lake, or watch rain fall from the sky, remember, you are witnessing the lifeblood of our planet. Water is the silent, flowing thread that weaves together the story of life on Earth. When we look up at the sky, at the sun, the moon, the distant planets, we're reminded that life on Earth is the result of an incredible cosmic choreography. Each piece of this delicate balance plays a vital role in making our planet not just habitable, but a thriving oasis in a vast, often hostile universe. It's easy to take this balance for granted, but understanding how rare and fragile it is helps us appreciate our home in a deeper way. From the fiery core beneath our feet to the gentle pull of the moon on our oceans, from the protective shield of our magnetic field to the giant guardians watching over us in space. These are the gifts that have made life possible. As we face the challenges of today and tomorrow, let's remember that Earth's balance is precious and worth protecting. Because this fragile miracle, this delicate balance, is the only place we call home. If you enjoy this content and want to explore more of the universe's strangest mysteries, don't forget to like, subscribe, and turn on notifications so you never miss a journey into the unknown.